I'm going to start a unit on roots and radicals. So we're done with the factoring unit for now, but that doesn't mean that we have to forget about it because it'll be on subsequent exams. But let's start with some vocabulary. Let's say we have radical 49, or the square root of 49. A couple of things. If there's nothing written here, it's understood that the index is 2. So if I neglect to write a number out there, it's understood to be a square root. If there's a 3 out there, then that's a cube root. So this is the index, which is telling you how many equal factors you're searching for. This is the radicands. And the whole thing is the radical. So the index on the outside here is 2, which means I'm looking for 2 equal factors which multiply to become 49. And in this case, the square root of 49 is positive or negative 7. Negative 7 times negative 7 is positive 49. Positive 7 times positive 7 is also 49. So therefore, the square root of 49 is both positive 7 and negative 7. But the principal square root is simply 7, just the positive value of it. So just that, now that we get some vocabulary out of the way, let's just work up to adding and subtracting fractions. But a couple things we have to learn before that. For example, square roots of fractions. Now the index here is 2 because there's nothing written, so that means I'm taking a square root. So if I want to take the square root of 4 over 9, I could take the square root of the numerator and the denominator separately. So in this case, square root of 4 is 2, and the square root of 9 is 3. So let's practice simplifying some radicals. Let's express radical 32 in simplest radical form. So what you're trying to do is break up the number on the inside into a product of 2 numbers. And I could express 32 as 16 times 2. You're really looking for a perfect square and a non-perfect square. So then we could break up the square root of 16 times 2 as the square root of 16 times the square root of 2. And I know what the square root of 16 is. It's 4. Therefore, simplest radical form is 4 radical 2. Now, what if we had variables involved? Let's say we had the square root of 27 x to the third y squared. A variable is a perfect square if the exponent is even, but we could still express odd powers as products. So let's break down the radicand. I could express 27 as 9 times 3. I could express x to the third as x squared times x, and y squared is already a perfect square, so I'm going to leave it alone. Now there's a couple ways you could express this. We could take the square root of each term individually. What I like to do is circle all of my perfect squares. To me, it's a little easier to see what I'm going to have left in the radicands. In this case, I'm going to have a 3x on the inside. So now I'm going to take the square root of each of these terms and express it as a coefficient. The square root of 9 is 3, the square root of x squared is x, and the square root of y squared is y. And then left on the inside, I have a 3x. Now what I could have done over here, rather than taking the square root of each term individually, I could have just said radical 9, radical 3, radical x squared, radical x, radical y squared, and then I could take the square root of all of these individually. I just don't like the way this looks. I think this is a little easier to keep track of, but this is your decision which way you want to approach it. Either way, you're going to end up with 3xy as a coefficient of radical 3x. Alright, so adding and subtracting radicals needs the skill of simplifying radicals. The reason for that, you can only add and subtract radicals if the radicands are the same. If the radicands are the same, then you can add and subtract their coefficients. For example, let's say we had 2 radical 2 plus 3 radical 2 minus 4 radical 3. Now there's no need to simplify these radicals, but in the end this is what you're trying to end up with. When you're adding and subtracting radicals that can be simplified, you want your radicals in simplest radical form, and if the radicands are the same, you can add them. So in this case we have radical 2, radical 2. I can add these two radicals because radicands are the same. This radicand is 3, so I cannot add it with any of these. So since these radicands are the same, I'm just going to add their coefficients. And you treat radicals just like you do x terms. 2 radical 2 plus 3 radical 2 is 5 radical 2. Just like 2x plus 3x is 5x. And the other radicands is not the same, so I'm going to leave it alone. Let's practice one more. Let's say we had x radical 12x plus radical 20x to the third minus x radical 45x. Now these are all square roots because the index is not written, so it's understood to be 2. If the index were 3, we would have to treat this a bit differently. So the first thing I'm going to do is simplify all of my radicals. So I'm going to express them all as products in the radicands. I could express 12 as 4 times 3. I could express 20 as 4 times 5. I can express x to the third as x squared times x. I can express 45 as 9 times 5, and the x I can't express any differently. So now what I'm going to do is one radical at a time, I'm going to simplify the radicands. Let's circle our perfect squares. The square root of 4 is 2. There's already an x there. So when you're pulling a number from the radicand out, that's a perfect square, you're going to multiply by any coefficients that are already there. There's already an x there. The square root of 4 is 2. So the coefficient is now 2x. And my radicand is 3x. Plus, square root of 4 is 2. Square root of x squared is x. Multiply them together, and that's your coefficient. 2x radical 5x. Square root of 9 is 3. There's already an x there. Let's multiply them together. 3x radical 5x. So now we have to look at the radicands first. 3x, 5x, 5x. So these two radicals I can add together because their radicands are the same. But we have to verify that the coefficients are also like terms. And in this case, there are. 2x minus 3x is negative x. So let's just copy the first term. 2x radical 3x. And then we'll combine these coefficients. Negative x radical 5x.